Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Internal X Sums by Orp. And, excuse me, here are the rules. 9 by 9 chaos construction rules apply. Divide the grid into 9 non-overlapping regions, each consisting of 9 orthogonally connected cells. Place the digits 1 to 9 once each in every row, column, and region. So for an orthogonally connected region, that means if you have a region, you should be able to go from any cell in the region, stay in the region just by going through edges, and connect to any other cell in that region. So this is a valid example of a region. This would not be because, again, to get from any of these cells to here, you can't stay in the region by just crossing edges. You would have to cross a corner here, which is not allowed. Same for this. This is not a valid region because even though they can connect to each other by going through edge, if you try to connect from any of these cells to connect to this by staying in the region, you would have to cross through a corner, not through an edge. And that's how chaos construction rules work. We also have digits and cells with arrows indicate the sum of the first n digits, where n is a digit in the closest cell to the clue in the direction of the arrow. Okay. Those n cells are all in the same region, beginning and ending with a region border. That is, the cell with the arrow and the cell after the nth cell are in a different region than the n cells. So, as an example, say this was like a 6. That would mean, actually, this would not be a 6. This is the sum of the first whatever digits. So n would be here. So it would have to be like 3 or something. Let's use this, actually. This is probably better. So say this was 6. This sum would be outside the grid, so it could be any number, but it would have to be the sum of the first 6. It would have to be the sum of the first 6 digits, and those would all be in the same region, and this would have to be in a different region, which is obviously it is because it's outside the grid, and this would have to be a different region because the cell after the nth cell are in different regions. So this would have to be like, I don't know, yellow or something like that. And that's what happens when you have n here, right? So the n is the first cell that the arrow points to in that direction, and then it sums up that many digits into, and so the arrow, the cell with the arrow in it is the sum of the first n digits. And then those n digits also have to, again, end. It's the same region, and they have to end with the however long n is, right? If an arrow is external to the grid, the cell with an arrow can contain any number, including a multi-digit number. Yeah, so that's what I was saying. This doesn't have to be, since the restrictions of 1 through 9 are inside the grid, this can be any number here. We also have consecutive pairs, where digits separated by a white dot are consecutive. So, for example, if this was a 6, this would have to be 5 or 7 to make sure that these digits add up to are consecutive, not add up to anything. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. This must be the sum of two digits. It cannot be 1. If it were 1, this would then be a sum of one digit, which would have to only be 1. So this is 2. This is the same region. So this has to be a different region. So we have a light region here. Obviously, the edge of a grid is a different region too. So that's fine. This must then be 3 through 9. And this is 1 through 7, right? It cannot be 2. So this can't be 2, this can't be 4. This is the same region. It cannot be 1. Actually, it could be 1. This could be 1, and this is 1. This could be 3. Actually, this could be 3 through 7. Yeah. Any of these are valid because as an n, because we don't have any restriction on the sum. This could be 1 through 4 for this arrow, for the n, but it cannot be 2. If this is 1, this would then be 1. So this is it could be 4, which would mean it could be can it ever be 2? If it's 2, it would have to no. So it could be 1 if this is 1. If this is 3, this is at minimum 3, 1, 1, which would be 5. So this is 5 through 9 then. So this is a separate region. It's green. It has to continue at least 3. So this is going that way. It technically could be all 9. That's fine too. This also has to be 2 here. So this must be the sum of 2 digits. And this must be a separate region. This, again, could be 1, 3, 4, 5, 6, 7. And this is 3, 5, 6, 7, 8, and 9. But this cannot be 9. It can only be this. This actually has to be a 3. Right? Because this is a single digit. And it's the sum of... It cannot be 4. It can't be 1 or 2. So this has to be at 3 digits to add up to what this digit is. So this is 6 through 9. This has to be a 3. This has to be 1 then. This cannot be a 3. This is not the same region as it, so it cannot be 8 or 9. So this is specifically 5, 6, or 7, which forces this to be 3, 4, or 5. So this light region has to go at least 3. This region has to go 3 that way. And this is a separate region. And we know this is a boundary. So this must be 1 through 5. That's possibilities. This is a sum of... It cannot be 1. It has to be 2 here. So this is 2. This can't be 2 here. This then is the same region, and it's pink. And this is a separate region. This has to be 3... Okay, so this is the edge of a region. So this is 3, 4, 5, 6... It cannot be 4. 3, 5, 6, 7, 8, 9. Which makes this 1... It cannot be 3. So this can't be 5. 1, 4, 5, 6, 7. Because all the pink region is the same region. This is 5, so this green has to go all the way here. At least. Okay, so this green cannot be the same region as the pink, because this is 5 already, this is 4, so that's 9, but then it can't connect. So this must be... These digit must be 5 through 9. This can never be 4, I don't think, right? It has 1, 2, 3, 4. Well, it could be 4 actually. That's wrong. Okay, what is this? What are these digits? This has to be 4 through 9. So this can never be 4 because this would be at minimum 4 and 4 added up together. Oh yeah, this is all the same region, so you can never have 4 anyways. So either this is 1. Oh, that's interesting. One of these, okay, so one of these is a separate region than the other, right? These have to be different regions. This light, therefore, has to be one of these regions. So the light cannot be both of these regions. I guess it could be green here. So this could be light. We're going to make this dark, actually. This looks like it's going to extend to here. These are separate regions. This could be green, though. 3, 4, and... This is at... If this is 3, this is at minimum 3, 4, and 1. So this has to be 1, or it's 8 or 9. We're not sure which. This is 3 plus 2, and that's plus 1. So this is 1 or 4. So this must be 6 or 9 here. 6 or 9 is consecutive with only 5, 7, or 8. This is 3, 6, 7, 8, 9. So if this is 3, that would force this all to be pink. And we would have a repeat here. So this cannot be 3. It can't be 1. This has to be a 2 then also. And is its own region. We're going to make this, I guess, yellow. And this will make orange, I guess. This is a separate region here. It cannot be 1 because then this would be 1 because it's a sum of that. Therefore, this is a 3. So all 3 of these are yellow. This is a separate region. We're going to mark it as blue. What's the sum of this? This could be what? 1, 4, and 5. There's no 2 involved. So 1 has to be one of these digits. So it's 1, 3, 1, 4, or 3, 1, 5, which makes this 8 or 9. 3 cannot be either of these. It can't be 2 either, so this could be 4, 5, 5, 6, 6, 7, 7, 8, or 8 and 9 here. This is 3, which forces this to be a 1. This can't be 1, so this can't be 3. This is at most... It cannot be 1, because one of these is a 1. Can't be 2, can't be 3, so it's 4 or 5 here. So this is a 1, 4, 5 triplet in row 8, which eliminates 1, 4, and 5 in the rest of the row. So that this means this is 2, 6, 7, 8, 9, 2, 6, 7, 8, 9 here. This is not one digit, so this has to be... This could be many. So it's at least 2 here. So this could be 2, could be 3, could be 4. It cannot, well, technically it could be part of this. So it could be up to 8. Right? Because this could be technically the same region. This has to be the same region. We're going to make that red. This could be... This can't be 1 because of the 1 here. This could be 1 here, though. So we don't know how far this goes. This can go up to 5. It cannot... Okay, so wait, no. It has to be 2 or 3 here. Obviously, this is a boundary. This can be... If it connects with the red, 1, 2, 3, 4. 1, 2, 3, 4, 5. 6, 7, 8. It could be 9. So this could be 1 through 6 here. What can be in column 7? It's 1, 4, 5, 6, 7, 8, 9. Right. This can't be 1 because of the 1 in the column. This can be 7 at most. No 2. This could be, this has to be at least 3. Okay. What else do we have? This cannot be 7. So this can't be 5 here. Okay, so this can never be light. Therefore, this always has to be light. So since this is light, this is 1, and this must be 1 then. So this can never be 1, this therefore it's part of red. Therefore, where is the rest of this? This has to be red, because it's blocked by this region. So the red could, this has to be 2 or 3. This is light. It can go, therefore, to connect this, at most, this has to be light also. To have a 9, because this can't be part of that region. Therefore, this is a separate region. We know this is medium. It has to go this way. These, then, it could connect here. We don't actually know if this is green or if this is light. This is a border, though. This cannot be 4 because it's either 2 and 1, or if it can never be 2, 2, obviously. It can't be 3 and 1 adding up because that would be, you would need another digit. So either this is 3 and 5, or this is 4 and 6. So 4 and 5 has to be in one of these two cells, and 4, 5 is here. So the rest of column 1 cannot contain 4 or 5. So it's 1, 3, 6, 7, 8, 9 as possibilities. 1, 3, 6, 7, 8, 9. This can't be 1. Let's see. This orange definitely cannot be part of this red region. This can't be 1 here. Oh, this medium gray region cannot be the same as this dark region. Um, this medium gray, though, could be... Okay. This medium gray could be part of the pink. We're not actually certain about that. Green is different from pink. Pink is different from dark. Light cannot be the same as pink, but this medium gray could be the same as this pink. Mm. Okay. Hmm. Uh, this is 2 or 3. I mean, it could be green like that, right? That's possible. Or something like that. Hmm. If this is 6, oh, that's interesting. So what are the potentials here? If this is 6 and this is 4, this is 5. So this has to go red here. That would make this a 2. This would have to be 8. None of these could be 2, so this would have to be 2. And this would have to be at least 3. This would be green here, so that would close off this. This would be 4. This would have to be all light. This would have to be all medium. Dark would have to go down here. Pink would have to go... It could go here. That's still valid. So far this is looking fine. This red is here. This has to be part of yellow or blue. We're not sure which. Blue cannot be part of this orange. This is separate. Okay, so how many digits are this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is too small. This would not have, this has to have 3 different regions. Because one of these is a 1. This has to have a 2. This has to be 2 and 1. This 2 and 1 must be different than this. These have to be different regions just because of the way the arrows work. So then this can never be 4 and 6 then. So we know what this is. This has to be 3 and 5. So this is 3 and 5. This is 4. This then is not 1. This has to be 9 and is a separate region. These can't be 5. This ends at 5 here. This ends here. So this must be medium gray. This has to connect somehow, so this connects this way at least. This is 1, 2, 3, 4, 5, 6, 7, 8 at most, so this has to be medium. This dark or this medium cannot be the same as a dark. So this has to be, the rest of this is medium. So this region is already set. This can be green or light. This could be light or pink or some other one technically. These have to be 4 through 9 here. 9 cannot be either of these two because this is 9. This is 1 and 5. These can't be 9 here. This cannot be 3. This can't be 3. This could be 3 here. We're not sure. This is 1. The pink has to go out either this way, or both. The green can go... What this can never be green, right? If this were green, oh, it could be green if it goes down here and this is some other region, right? If this is orange, okay, it can never be red here. Can it be orange? If it's orange, this is 3 digits, right? And then it has to be 1, 4, 5, 6, 7, 8. I guess that's possible. But the yellow cannot go this way. This could be orange though here. That's fine to be orange. Blue could go this way too. So this is orange or blue here, right? Red can only extend one more this way. This could be orange, blue, or yellow. This could be orange, yellow, or blue. We don't know about how far that goes. This dark gray. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 6, 12, 18. But this dark could be part of this region. So this can't be 8 anymore. So this blue technically could be part of this dark region. And in fact, I think it has to. If this was not... Okay, this blue is obviously not part of yellow. Say it's not part of dark. It can't be part... Actually, it could be part of orange. If this is... This could be pink or dark, right? But if this were pink, that would block the dark region off. So this can never be pink. This has to be dark. I guess it could be blue, technically. Right? You could have 1, 2, 3, 4, 5, 6. There's just not enough region for that to be blue. If this is blue and it's a separate region. Dark is obviously different than orange, right? If this is 2, that forces this to be 2. Cannot be part of yellow, can't be part of orange, can't be dark. So this would have to essentially be the same region, sorry, a different region. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 for the dark region and the yellow region. Therefore, you need at least 3 more for the yellow region, which would mean this is yellow. But then you wouldn't have enough space for the blue region. So this cannot be 2. If this is 2, that eliminates 2 here, which forces this to be a 2 and its own separate region from yellow and dark and orange. So this has to be then a 3, which means red cannot go this way, red cannot go this way. It has to specifically be this region. So this is the region of 3. this has to be a separate, either dark or orange. So this is, we're going to make this orange or dark. Obviously, if it's dark, it cannot reach all that way here. It can reach 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could get to here. It could be part of orange. We don't know. This could be part of some other region, blue. These could actually be part of some blue. We know this has to be the same, though. This could be yellow. This can't be 3. It could be 2. No, it cannot be 2 because then it would be some other region. So this can never have a 2 here, which means 2 has to be here. So we know 2 is one of these. This is 6, 7, or 8. This has to be 4 or 5. So this is orange or dark. It's probably dark would be my guess. But we don't know. This is a separate region. So this is dark or orange or yellow. Yellow, yeah, this is at least 4. It's 4 through 7 here. This cannot be yellow. If it's yellow, that blocks off the dark. Or it blocks off the orange here. And this is not allowed. So this can't be yellow. This could be dark orange. This is dark orange or yellow. Pink cannot go here. Pink can't go here. It would block up the dark. Where does this pink go? We have 1, 2, 3, 4, 5, 6 at most. So this would be 7, 8. So these both have to be pink because this is a boundary here. This is a boundary here. Therefore, it blocks this. This is 4 through 9. This is 4 through 9. One cannot be here. Therefore, 1 has to be one of these 3. Which means this can't be 1. It's 2, 4, 5, 6, 7, 8. This is 2, 4, 5, 6, 7, 8, 9. Can this ever be green? No. So this is orange or blue here. It can't be yellow or dark because those can't reach. It can't be pink because that can't reach. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could be blue, orange, or green. Can it ever be pink? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So this is blue, orange, or pink. This is blue or orange. This can never be green because if this were green, this would be then size 9. So this is blue or orange also. This can never be, well, this could be green if it goes this way. There's only one way to access this. How? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and then 26. We know there are 3 regions here. And there's only one way to exit out. And there's only 26 cells in this region. So this cannot have a 4th region. So this is orange, yellow. So this has to be orange because it can't be dark. These then both have to be orange. because it cannot be yellow and it cannot be dark. So this is 26, right? So this is 20 here, maximum, and then 6 here, maximum. So it needs to extend one more here. So these can never be orange, because, so therefore this is blue, which means this can't be blue. This has to be green, and it cannot be 3 then. This is 2. So it must go 2 this way, because otherwise if it continues that way, it would essentially be 4. So this has to extend, either go that way or go this way. We're not sure which. This actually, well, it could be. This could be blue, right? So green goes, this is not green. It could be pink or blue. This could be green or blue. Actually, this can't be green. This is blue. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that can only reach here. So orange could reach 2 spaces. So this could be orange, because we have, again, 26 at most already for these regions, but the pink could remove 1. So then the orange could access 2 more here. But it cannot reach here, so this must be blue. One of these could be green, pink, or blue. Pink could be any of these. Pink could be here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this cannot be green. This is light, which means this can't be light. This is pink. We have 1, 2, 3, 4, 5, 6, 7. So only 2 more. So this can't be pink. This has to be blue. 2 more. So 1, 2, 3, 4, 5. This can't be green. I guess it could be blue, technically. Yeah. Blue can be any of these also, actually. So blue, so pink goes 1, 2, 1, 2, 1, 2, 1, 2. So none of these can be pink. This is blue. Yellow needs access to a 2. This can't be 2 here. Can this or ever be orange? No, because we have 5 oranges here. Because this can't be yellow, can't be dark. These are all orange. So to access these 2, it has to be orange. So this has to be all dark, which means this is 7. This cannot be 7 here. Therefore, this can't be 7. These can't be 7 either. So this is either 8, 9, 4, 5, or 5, 6. 2 is one of these 3, so where is the 2 in this region? It has to be here. Sorry, in row 9, where is the 2? It has to be here. And this 2 cannot be orange, because orange already has a 2, so this is yellow, which means this has to be yellow. This can't be orange anymore, because it's blocking. So we have 8 darks, so these cannot be dark. This is yellow, this is yellow, this is yellow. This cannot have a 5, so this has to be an 8, 9 pair. So this is 8 and 9 consecutive. This yellow already has 3, 1, 5, and 2, 8, 9. So it needs a 7, a 4, and a 6. The start could be any of these 4, or any of these 5, rather. 7. One of these has to be a 2 here, because for the dark region, there's no other place for the 2. This is red. This is yellow, or it's dark. Sorry, yellow or orange. Both of them already have a 1, and both of them already have a 9 and a 2. So this cannot be 1 or 9. This can't be 1 or 9. Um, This is 3 through 8 here. So this is a boundary. This has to be a boundary. This is a boundary. This is a boundary here. So this is 4 through 9. What digit is this? It cannot, this is not consecutive. 3 cannot be here because it's not consecutive with 6 or 9. Therefore, this is a 3. The remaining digits in row 2 are, one of them is a 4, so this light medium region cannot have a 4. So this 3, this dark region is missing a 3. Therefore, this cannot be dark because this has to be 3. So this is not dark, which means this has to be yellow, cannot be orange. So it can't be 5, this is 4 or 6. The yellow can only access 2 more. So it could be either 2, if it goes 2 here, that's 2, it cannot be. So this can't be yellow. This has to be orange here. It could be either 2 here or 2 here. And this can't be yellow. So either way, if this is 2 yellow, okay, so this is a border. If it's 2 yellow, can it be 2 yellow here? I guess. Orange, right? This is orange, this is dark, this is pink. That's possible. So I think this has to be yellow no matter what. 1, 2, 3, 4, 5, 6, 7, 8, and then 9 here. That's possible. So this cannot be dark because if it is dark, it would have to be a 3. So this is orange, which means to connect to the rest of this has to be orange. So this must be this is the only dark left, which makes this a 3. So this is a border. This is a border here. This is a border here. This is the last yellow. So that's the only ones possible. We have 1, 2, 3, 4, 5, 6, 7, 8. So these cannot be orange. Since this can't be orange, these are all blue. So it's 5, 6, 7, 8 blue. Right? Because this is either, well, this blue has to connect here. And it's 5, 6 or 5, 6, right? Okay, this can't be pink. If this were pink, that would block either the blue to connect or the green to connect. So this can't be pink. We have 1, 2, 3, 4, 5, 6, 7. So it's either 1, 2, 1, 2, or 1, 2. Orange can be either of these. I don't think this can be blue. If this were blue, you would have 5, 6, 7, 8, 9, 10. Yeah, and that's not possible. So this blue could be 5 here, 6, 7, 8, and then one of these 3. That's fine. The blue region needs access to a 2. So it has to be 1. It cannot be here. Okay, this can't be 2. So it cannot be here. So the 2 actually has to be one of these 2. So if this goes green here, the blue would have to be here. 1, 2, 3, 4, 5, 6, 7, 8, and would not access the 2. So this cannot be green this way. This has to be blue this way. And this is green. So this is a border. This is blue. 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. One of these is blue. One of these is pink. One of these is orange. Okay. This has to be 1, 4, 5, and 6, but there's no 4. Therefore, this is a 4. That's the only remaining digit that we're missing. This 1, 5, 6 triplet eliminates 1, 5, and 6 in the rest of the region. This is a 2, 7, 8 triplet, which forces this to be 9. None of these could be 9. Therefore, this can't be 7. This has to be a 6, 7 pair here, which eliminates 6 and 7 in the rest of the row. So this can't be 6 or 7. This can't be 6 or 7. Therefore, this can't be 4 or 5 to add up with 2 to add up to this digit. This can't be 6 or 7, so this is 1 or 8. Remaining digits are 3, 4, 5, 1, 3, 4, 5, 8. And this can't be 1 or 3, so this is 4, 5 here. This can't be 1 because of the 1 in the orange cell, so one of these is a 1 in the blue region. So the blue region cannot contain any more 1s. One of these is a 1 in the green region. Yeah. The blue cannot contain 1, so it's 3 through 9. Remaining digits in column 5 are 3 through 8, but you can't have a 3 in the pink region. This is orange, so this cannot be 9, which means this can't be 7. This can't be 9, so this is 3 through 8, and no 4 is allowed here. This digit in column, so this has to be 2 here, which means this is a 4, 5, 6, 8, 9 quintuplet here. These two digits must be the same as these two digits. Because they are not duplicated here, it can't be the 3, it has to be these two digits then. Four cannot be either of these cells, so 4 has to be one of these 4, which means this can't be 4. This is a 2, 7, 8 triplet, which eliminates 2, 7, 8 from the rest of the row, so this is 6. None of these could be 6 then. One of these is 1. This can't be 9. This is 4 through 8. This is 4 through 8. There's a 3 in one of these 3 cells. And it cannot be pink, it cannot be blue, and it has to be orange for that 3. So this can never, okay, well, this can't be 3 anyways. This cannot be 1. Where is the 1 in column 8? It has to be here. So this is 1, this is 5, which means this can't be 5. This is a 5, 6, 7, 8 quadruplet in column 8, which means the remaining digit has to be a 9. So this is 9, this is 6, this is 1, because this 6 must add up to 3, 1, 2. This 6 is consecutive with 5 or 7. 6 cannot be any of these. 9 cannot be any of these. This can't be 6 either. So 6 is one of these two. It must be with 5 or 7. We're not sure which. This is 2, 1, 3. This 6 eliminates 6 here, so this is 7. This is 6. These can't be 6. So we have an 8 in one of these two cells, which means 8 cannot be in the rest of the orange region. This can't be 4, 6, or 7, so this is 4. This can't be 4, 5, 7, so this must be 8, which makes this 9, which makes that 8. So 8 cannot be here. 8 cannot be here. One of these is a 4. We're not sure which. 5 or 7's here. This can't be 4. This can't be 4, and this can't be 4. And neither can these. Let's see. Okay. Okay, this is 7 or 8, so this must then be 5 or 6 here. Oh, this is not pink because it has to be, again, this has to be a boundary here. So this is orange, which means this can't be orange. These both must be pink to fill out the region. So this is the full boundary. This has to be a 2 because there's no other place for the 2 in this blue region. This can't be 8. It can't be 4. This is 2, which means this can't be 2 here. So where it's a 2 in the red region, it has to be here. This can't be 1. Where is the 1 in the green region? It's one of these 2. That doesn't tell us very much. We have a 4, 6, 7, 8, 9 quintuplet in the green region. So this cannot be 6, 7, 8, 9 here. So this has to be 1, this has to be 3, which forces this to be 5. This 1 eliminates 1 here, so this is an 8. This 1 eliminates 1 here, so this is 6. Therefore, where's the 1 in the blue region? It must be here. This can't be 1 here, and it can't be 6, so this is 5, which makes that a 1. This can't be 3 or 5, this can't be 5, and this can't be 5. So this is a 6, 7 pair in row 1, which eliminates 6 and 7 in the rest of the row. So this is a 4, 5 pair in the medium gray region, which eliminates 4 and 5 in the rest of that region. So this is 7, which means this can't be 7. This is 8, so this must be 2 and 6 added together. This can't be 3 or 6 here. This 8 eliminates 8 here. This is a 5, 7 pair in the orange region, which eliminates 5 and 7 in the rest of the region. This can't be 5. This is 3. This is 6. 8 can't be in the rest of the blue region, and this can't be 6. This can't be 6 or 8. This can't be 6 here. We have a 5, 7, 5, 7 pair in row 6, which eliminates 5 and 7 in the rest of the row. So this is 9. This is 7. This can't be 5 or 9, so this is 8. This can't be 5, 7, or 9, so this is 3. There's no 3, 5, or 9 here. This can't be 5 because of the 5 in the region, so this is a 7, which makes this a 5. This can't be 5 or 8, so this is 4. No 4 or 8 here. This is a 5, 9 pair. This 5 eliminates 5 here, so this is 7. This cannot be 7 or 6. So it's a 4, 5, 8 triplet. This can't be 7 here. Where's a 7 in row 3? It has to be here. So this is 7. This can't be 6 or 7 here. This can't be 7 here. This can't be 7, and this can't be 7, 8, or 9 in the blue region. So it's 4 or 6. This has to be 4, 5, 8, 9 as possibilities in the pink region. which means where is the 6 in column 4? It has to be here. So this is 6, which means none of these can be 6. This 6 eliminates 6 here, so this is 4. This 4 and 8 eliminates 4 and 8 here, so this is 5. That makes this 9, which makes that 5. This 4 eliminates 4 here, so this is 6. This 6 eliminates 6 here, so this is 7, 6. These can't be 7. That 7 eliminates 7 here, so this is 8, this is 7. These can't be 4 anymore. This can't be 8 anymore here. These can't be 5. Well, we need a 9 in row 4, so this has to be 9, which means this can't be 9 here. This 5 eliminates 5 here, so this is 4, this is 5, this is 4, which eliminates 4 here, so this is 9, 4. 9 eliminates 9 here, so it's 8, 9. This 4 eliminates 4 here, this is 8, 4, 8, and this must be a 5. And that's the solution. Yeah, it didn't seem too bad. It didn't seem really hard per se. I would consider this about a challenging level puzzle. Seemed fairly straightforward about how to go about things and how to construct things. So, I don't know. Maybe I've done too many chaos constructions puzzles, so maybe it's easier for me. I don't know. What do you guys think? Did you guys think this was a hard chaos construction rule or puzzle, or did you think this was more challenging level? Anyways, let me know in the comments, and I'll see you next time on Frank Puzzles. Take care.